All right, I reckon we should get started. Everyone hear me okay? Just pop a thumbs up in your Zoom if you can. All right, good evening. Thank you all very much for coming. Before we start, I would just like to acknowledge the traditional owners of the lands on which we operate. For me, that's the Wurundjeri people of the Kulin Nation. And in doing so, we pay our respects to their elders past, present, and emerging. And we also recognize that sovereignty was never ceded. So hello and welcome for giving up an hour of your time to come listen to us and to come tonight to our introductory talk. My name is Alan. I'm currently studying the Doctor of Medicine. I'm in my third year at the University of Melbourne. And my position within MBSI is the chair. So a couple of housekeeping things before we move on with our intro event today. Firstly, is that this event will be recorded, and we will be posting the entirety of the recording onto our Facebook as well as our website. So that means that if you have to run off at any point, absolutely fine, because you can always find the recording again online. This should take about an hour, give or take. I am aware that we started a little late today, but that's all right. We'll just we'll try and speed through things and finish roughly on time. Feel free to ask questions throughout in the chat. We will have a couple of external speakers here tonight. And so you are welcome, more than welcome to direct your questions towards either them or towards us, the organization as in general. And then we'll answer your questions either in the chat itself or at the Q&A session that we've got planned at the very end of this talk. Right, so the agenda for today's talk will be, if my slides progress, which they don't seem to be. Apologies. Yeah, so the agenda for today, this is not in the order in which we'll be presenting it, but roughly we'll be going through a couple of things. So firstly, what actually is MBSI? That is, how do we get started and what we want to do with it? I'll be giving you a very brief overview of the volunteers that we're very lucky to have within the organization, the activities that we want to do and that we want you to get in on as well. And lastly, we've got our guest speakers who will be, sharing with us their experiences in medical technology and why we should all be excited about it. So what actually is MBSI? So as you can see here, like MBSI stands for the Melbourne Bioinnovation Student Initiative. You can also call it MBSI if that is how you would like to pronounce it. So we started last year when a couple of us sort of were medicine students at the University of Melbourne who ran a Python workshop course for our fellow peers in late 2020. In addition, a number of us are also undergraduate science students who took part in this iGEM International Synthetic Biology competition. We got together sort of late last year and we really had to think about what there was at Melbourne, and we realized that there really wasn't an organization at Melbourne solely dedicated towards getting students involved in Medtech, that is bringing together students from many different disciplines and to get involved in medical technology. So that's where we decided that we should probably start our own thing. And here we've got our timeline of what we did and when. As you can see, we started late 2020, and actually at the beginning of this year, we received registered charity status as well as incorporation status. So we are henceforth a registered charity and we're able to commence operations. What exactly is MBSI? Well, it's roughly in the name. So we are a bunch of students based at Melbourne, and we are very interested in medical technology and biotechnology and all that intersects between. So while we are like primarily a student organization, that is currently all of our volunteers are students at the University of Melbourne, we don't think that we need to be limited to that. In fact, we welcome members from everywhere. So you don't have to be a student at Melbourne. You don't have to be a student at all. As long as you're interested in medical technology and biotechnology, we welcome your input and we welcome you to join us. With regards to what we actually want to do as MBSI, so our mission is to expose young people to medical technology and biotechnology, which are fields that we think lie at the intersection of multiple disciplines, those combining science, medicine, engineering, and commerce. So the whole point of really starting up MBSI was realizing that at the University of Melbourne, for example, because we can't do double degrees as students, or once we graduate, we're often into very selective postgraduate courses such as medicine or engineering, there really isn't much of an opportunity for us to engage with other things that lie outside of our immediate discipline. Whereas we think that medical technology is a very, very exciting field, but also a very interdisciplinary field. So we really need to be exposed to those other areas in order to actually work in this sector. And so MBSI tries to fill that gap and tries to expose students to this interdisciplinary space by getting people involved in disciplines not immediately within their education. So we've got a number of activities or domains of our operation. So firstly, projects, secondly, education, and thirdly, events. We've got members from our committee who are in charge of these various activities, and we'll hear from them tonight as to what each of these specifically entails, so I won't dwell on them too much right now. In terms of how we're structured, so we have a 5-person executive. I'm the chair. I have 2 really, really awesome vice chairs, Ryan and Betty, as well as Kevin and Thanushi, our treasurer and secretary, respectively. We also have a wider committee. So Alina at events, Carl with projects, John with sponsorship, and Anya with education. And we also have our 4 project leads currently, Edmund, Chang, Rory, and Poe. So as you can see throughout these slides, we all come from a very diverse range of educational backgrounds. For example, we've got a number of students who are doing the Doctor of Medicine, we've got a number doing the undergraduate Bachelor of Science, and also a number doing Masters of Engineering. So we really sort of embody as a committee this idea that we want to have students really be from all of these different backgrounds working together on the shared passion that is medical and biotechnology. So here's a little flow chart of where we sit. In addition to the executive and the committee, which I've already spoken about, we also have a number of subcommittees where we draw in other volunteers who are helping out on specific things like projects, workshops, or events. For the more eagle-eyed out of you, you might have noticed that there are a few positions here currently not represented. And so we're actually we're actually actively trying to recruit for these positions. So right now we have 2 openings on our committee, an IT officer as well as a pubs and promos officer. So if you think that you want to get involved with us by joining our committee and helping to steer the organization, as well as having an interest in either one of these domains, we highly welcome you to come join and apply for these positions. I think applications are open till mid-April, but we will be doing interviews on a rolling basis. So try to get your applications in as soon as you can so that we can interview you and onboard you during that process. And here are QR codes that you can scan on your phone, but also I think links are being posted in the chat to the position descriptions as well as how to apply for these positions. Awesome. So that was just a very, very brief overview of the organization. As I've said, we will be hearing from more people within the committee, specifically to do with projects, education, and events during the course of tonight. But first, I'm going to take a little segue and introduce our first external speaker. So Professor Graden is the Clifford Chair in Neuroengineering at the University of Melbourne, as well as the Graham Clark Institute. He is also the coordinator of the Biodesign Innovation postgrad course at the uni. He's got research links all across the country, ranging from hospitals, universities, and research institutes. Over the last few months, MBSI was fortunate enough to have Professor Graden offer us advice and guidance throughout our founding process. So please welcome Professor Graden, who will speak to you about his experiences in Medtech and also why you should be really excited about this field. If you have any questions for Professor Graden, please post them in the chat and we'll ask them on behalf of you at the end of his talk. Professor Graden, if you're there, very welcome to speak now.
Okay, thanks, Alan. Would it be possible for me to share my screen, please? Okay. Okay, so you should now be able to see my title slide. Yeah, thank you very much for that introduction. And yeah, it's great to see this initiative. I'm very pleased to hear about it because I'm very keen on biodesign innovation. And if I can also get slides to advance, there we go. So I was asked to give a bit of an overview of biodesign innovation, and it's important. So first, a bit of background: biodesign innovation is a collaboration between the Melbourne School of Engineering and the Melbourne Business School. It's inspired by programs at Stanford University and Hebrew University of Jerusalem, and we bring together teams of Master of Engineering students, that mainly being biomedical engineering, and also Master of Business Administration students from the Melbourne Business School. The biodesign innovation process looks like this. So 3 I's. There's identify, invent, and implement. And we're very strict that we want students to follow through this process. So identify is where students do observation studies. And so ideally, we send them into hospitals, meet with clinicians, follow them around, and just see where there are unmet needs. However, last year, and looking like this year as well, that's not really possible because of the COVID situation and the directives from the Chief Health Officer. So then after finding a lot of needs, and typically teams will find between 20 and 200 needs per team, then there's a needs screening process that needs to be done to find out which of these needs are really ones that you want to work on. And then after a need has been well identified and chosen by the team, then we move into the invent stage. And it's very important that in doing the needs finding exercise, that students don't, or that participants in biodesign innovation don't invent something as they're doing the needs screening, because we don't want ideas about how to solve a problem influencing whether that problem really needs to be solved. But then in the invent stage, we get to that with concept generation and sort of brainstorming. What are all the different ways that we might go about solving a need? And as part of that concept screening, the teams also consider intellectual property, whether there's freedom to operate in these different areas, what are potential business models that could be used, and what are the regulatory and reimbursement requirements going to be. And then finally, so this is all in the course done in semester 1. And then semester 2 is largely dedicated to the implement phase. And that's where you actually take one of these concepts and build and test it. There's different degrees to which they can be built and tested because there's only one semester to do it. But what we found is that teams have gone from nearly complete sort of simple devices through to just really basic sort of prototypes of more complex ones. But also there's strategy, sales, and marketing to consider, and the market entry models. And at the end of the course, the teams are expected to deliver a prototype and a business plan. So what's it like? Well, needs finding, doing observation studies in hospitals is a lot of fun. It's very eye-opening for students who aren't doing medical degrees or haven't done medicine before. The concept development is a lot of whiteboarding, a lot of prioritizing and thinking of wild ideas as well as less wild ideas, but you don't want to discount anything until you've really given it a proper bit of thought. And then there's the implement stage, and there's 2 aspects to this, actually getting into a lab or a design and build lab and putting something together and testing it, and then also developing the business model. And this shows an example of using a business model canvas to look at all the different aspects of a potential business. So we're fortunate in Melbourne that we can engage with leading clinicians at the hospitals here in Melbourne, and you can see here a bunch of the hospitals that have been included, and I think I've even missed some. We don't restrict students to attending certain hospitals. They're free to pretty much go wherever they can get an open door. We also draw upon experts and practitioners across different areas, people who've been there and done that with their startup companies or running major corporations, people who have expertise in teamwork, and also clinicians come and speak. A lot of experiential class activities, a lot of getting to know each other at the start and then sort of working together to solve problems. I think also bringing together students from different disciplines really makes a difference. And so that's really where I commend MBSI in really wanting to bring people together with different backgrounds, because I think that not only does it make it lively, but it also makes it a really incredible learning experience. And it's an impactful program because there are a lot of unmet needs. So of course, a lot of these are going to be dead ends that people pursue, but a lot of them have actually gone on and opened pathways for interdisciplinary collaborations, but also many of the graduating teams have created startup companies. Actually, more than half of the teams that have done that so far. In particular, Navi Medical Technologies is one of the shining stars from the first year that we ran the course, the 2016 alumni. They were finalists in Medtech's Got Talent. They entered the Actuator Accelerator, the Texas Medical Center Accelerator, the Melbourne Accelerator Program, and many other things. I'd just like to finish with something that might encourage you. Hopefully this will show okay. Might need to turn on sound. There we go. So this is from Federal Parliament. And we'll just finish with this, if it'll work.
There are many other businesses here in Australia that are manufacturing medical products that are also great success stories. Now, many of us here would be very familiar with the Cochlear story and the work that they have been doing with their hearing technology solutions. And of course, I've already mentioned ResMed and what they did with ventilators. But there are so many fledgling companies that are producing medical products right across Australia that we as Australians should be so proud of them and the work that they are doing. And they are great examples. Now, there was one business, it's actually a Melbourne-based business, it's Navi Medical Technologies, and last year this government backed them with a grant of $400,000 to help them commercialise their new catheter technology for seriously ill babies. Now, during COVID, even faced with enormous challenges, they expanded their businesses, they employed an extra 6 people, they set up an Aussie-owned office in the United States, and they significantly progressed their clinical researches. This is the work that Australians are so good at, and that's why when this government established our manufacturing roadmaps, we actually looked at making sure that there was a place for medical products manufacturing, because we have the capability here in Australia. What we will focus on now is building our capacity.
All right, thank you very much. Hopefully that also shows you that Australia is really wanting to back this sort of medical technology. So more power to you.
Thanks so much, David. And anyone who has any questions, please either raise a hand or type your question in the chat below. To start off with, David, I have a question for you. So what are typically students' greatest takeaways from this subject, even if their project hasn't progressed beyond the course?
Well, what I hope is the greatest takeaway, and what often is, and maybe John can comment on this, is the need is paramount. So there's that no matter how cool some tech might be, if it's not meeting a need, then it's not going to go anywhere. So if you put the need first, then it could be a simple technological solution. It could be hard, but it's probably more likely to succeed.
Amazing. And secondly, what is the biggest challenge that student teams typically face during the biodesign innovation process?
The biggest challenge. I think it potentially it's just the immensity of the task. You know, we really throw them in the deep end, but I think that they tend to flourish anyway. And but I think it's making sure that they have considered all of the different aspects that need to really be considered, because medtech is quite complex. So we always need to consider what are the regulatory restraints going to be. You know, what's the IP? Who's going to pay for it? You know, and those things that normally that you normally don't even want to think about, but are really important to think about.
Definitely makes sense.
Great questions, thanks.
Yeah, and John, do you want to share from your personal experience of the process, what was your greatest challenge?
Yeah, sure. Well, everything David said is, well, quite correct. And he's an expert in this journey, I think, at this point, having experienced so many different teams and been teaching it for so long. Personally speaking, I did it in 2019. I think the biggest challenge is sometimes trying to figure out also, you know, touching on to all those different elements that David did mention, say regulatory, IP, you know, all the FDA, TGA pathways you may have to follow in that regulatory space, the funding, the business elements, your market entry journey, and then how you're going to exit. I think these all also start coming into play in terms of how you develop the product, and at times early on, even how you even choose your need, because need is the most important one. And often, you know, it's very good to be passionate about things, but it's also very important to be not blind. So you can be very much at the sort of risk of also falling for something that may not have a long-term potential for one of these reasons. So it's a big challenge to understand how you have to integrate all of them together. And I think teams that do that really well are the ones that go really far. And just in addition to that, I guess, look, this is something that's always said in a startup space. And I'm only saying because David did say more than 50% of them do go into sort of a startup journey, a company. Team is like terribly important. It's actually, they say, one of the, arguably the biggest reason why 90% of the startups fail. And that is a really, really important thing, more than you may think that a product may be important or necessarily the need as well. If the team is not there, nothing materializes in the end. So those were the challenges, but I think when you finish it, it's a very new perspective, appreciable new perspective you gain for life.
That's really insightful. And thank you so much, David, once again, for not only your support of Embassy, but also for a fantastic talk today. So it's my pleasure now to introduce our next speaker, Carl Singh, who is the projects coordinator for Embassy, and he is in charge of all of our project groups, and can't wait to hear what he has to share about this program.
Thank you, Betty. Good evening. My name is Carl. I am a second-year medical student. Before going into medical school, I had an experience in undergraduate bioengineering and bioinformatics. So I'll be talking to you about the project team today, which will offer you such a fantastic experience, and we're really looking forward to project this year. So can I get the next slide? Yeah, so I'm the project coordinator. What I do, I'm really just playing a facilitating role for all of our amazing project teams. And I try to use my experience working with different teams to help our project work on their project structure, their team dynamic, and set feasible goals for each of the project. And what are the MC projects? Well, it's a year-long project that targets a real-world problem in the space of healthcare and medical technology. It offers our volunteers a very unique experience because you get to know the team for a whole year, and you get to do cool stuff that's in real-life settings with real academics. And it's also a very open-ended endeavor because this is sort of your project, and we want you to be really involved and invested in where this project leads to. And it'll be rewarding because hopefully you get to address a problem and find a solution to it. So what sort of solution are we hoping to devise for our problem? We understand that all of our members are students, and what we aim for is to make a small contribution towards a bigger problem that someone has identified clinically. And that contribution can be a publication, a literature, or it can be a software or hardware application that plays a small part in implementing a clinical or hospital-based medical technology. So how can we help you do this? We can help you find support from academics. Before starting this endeavor at Embassy, we really weren't sure how well this project idea is going to float, but we contacted many academics and we received overwhelmingly positive report from those academics. And we think there are plenty of support that we can provide you. Later on, you hear about the education branch, which will design specific activities and trainings for our project leads to help them succeed in their project. And each project will have a mentor that's from an academic or a clinical setting. Yeah, so together it'll be a very unique opportunity. And I think you've gotten tired of hearing from me. You should really hear from our fantastic project leads. So Next slide. So this year we have sort of designed 3 projects, one on radiology, on brain-machine interface, and the third one from Edmund, which is still in its development stage, is an app for Western health surgery patients. Without further ado, I'll pass it on to our project lead, Rory.
All right. Hi, everyone. My name is Rory. I'm leading this project together with Chen. Chen, give everyone a wave. Say hello.
Hey, guys.
Yeah. So we're both medical students with a background in software engineering and machine learning. And so we're the project leads of this project. So what do we intend to do? Next slide. What are we intending to do? We're collaborating with Austin Radiology AI Lab to hopefully design a machine learning algorithm or application that will assist with clinical or research radiology workflow. So why do we want to do this? Well, we think AI has a lot of potential in helping us delivering medicine, and this project would be a fantastic opportunity to explore how that could be done. The Austin Hospital has over 10 years worth of radiology data, both images and text. And this is a fantastic opportunity to try to make something great from the data. So some possible applications would include, next slide, yeah, would be like detecting disease, assessing like when images should read, like in terms of how severe cases may be, or calculating indicators that will help doctors make better decisions. We're looking for keen medical and software engineering students who hope to participate in this. Like, even though we'll be using quite advanced methods in this project, we don't expect it from the applicants. What we hope for is a understanding of like the radiology and technology, like basic, and a keenness to learn. And yeah, if you're interested, give us a shout. Links to the application forms are throughout the at the end of the presentations. All right, thank you. Next, I'll move on to the second project.
Hi, everyone. Great to see you all here. My name is Poe. I'm a final year electrical engineering student and a project lead. Now, I'm sure all of you have heard of Neuralink in some shape or manner, and if that interests you, stay tuned, as Carl and I are leading the Brain-Computer Interface Research and Development Project under the guidance of Dr. Sam John, who will be talking to you later. He's the Senior Neural Engineering Lecturer at the University of Melbourne. Next. So why brain-computer interfaces? Ooh. Yeah. Well, there are millions of people today who are not able to use their limbs due to a disease or because they lost their limbs entirely. This may be because they suffer from neuromuscular diseases and have muscle wasting, or they suffered a stroke and now have paralysis, which means they're often unable to do daily activities and end up losing much of their independence. For these people, we can potentially bypass the damaged part of their body entirely and convert the intent to commands by directly accessing the brain, leading to what we call brain-computer interfaces. Here we see a photo from the amazing Cybathlon competition, where they pushed the limits of rehabilitation engineering. One of the events is a BCI controlled race where they have to operate a car or a person and navigate a complex course. Next. So for my project, I'm interested in developing ways we can use machine learning methods to extract features from neurosignals and allow a person with no motor control to operate external electronics to complete a specific task. Just some examples of what we could do are, for example, recreate typing, typing without using your hands, driving a wheelchair, operate robotic prosthetics, or potentially even help facilitate the rehabilitation they're already undergoing. Next. And the way it's going to work is in 2 streams. The research stream will be mainly for people interested in doing original research, so novel applications and publishing papers. And this might be more suited to the medical students. And the product development stream, which will be more focused on replicating and making the BCI systems from literature more viable and actually making an end product. So if that interests you, we are also recruiting, so please come join. There will be info sent into the chat, and which will include the more in-depth project description and an application form. So applications closes this Saturday, so that's very soon. Thank you, everyone, and I hopefully get to see some of your applications. Next, I'll pass it on to Edmund.
Great, thanks, Poe. And hi, everyone. Thanks so much for coming. My name's Edmund. I'm also a project lead and a final year medical student based at Western Health. Now, have you ever wondered how smartphones, which just about everyone owns, can augment clinician workflow and improve patient outcomes? Well, stay tuned, because for our project, we're building a mobile app that assists patients undergoing colorectal surgery. Next slide, please. And we won't be doing it alone. In fact, we're collaborating with a fabulous team of doctors and scientists, including Associate Professor Justin Jung, a colorectal surgeon himself. Next slide. So the problem we're tackling is twofold. It's poor surgical outcomes and patient engagement. Let me tell you what I mean. So colorectal cancer is one of the 5 most common cancers affecting Australians. Our surgery can cure certain patients, but as with most things in medicine, it's not without risk. Patients with underlying health conditions, such as those with obesity, heart disease, or those who are frail and underweight, they take longer to recover. They're at high risk of complications, and they're less likely to return to their previous quality of life. Imagine if we could identify this group of patients so we could tailor their treatment. The second thing is patient engagement. Multidisciplinary care is the best practice in colorectal surgery. It involves not just a surgeon, but a whole team of other professionals like dietitians, physios, OTs, social workers, to name a few. It must be pretty confusing to keep track of it all as a patient, if you ask me, especially when 1/3 of the patient demographic at Western Health are from culturally and linguistically diverse backgrounds. So what's the solution? Next slide. Well, we're going to design an app that does the following. Number 1, it provides clinicians access to an algorithm that identifies this high-risk group based on factors such as body composition as determined by CT imaging. And number 2, delivers educational and therapeutic content from other professionals in the preoperative and postoperative periods. Imagine a tailored nutritional plan for preoperative optimization, or hourly smartphone reminders for deep breathing and coughing. If this piques your interest, applications will be open shortly for the medical and technical teams. Feel free to shoot me a message in the meantime if you're interested to find out more. Thanks, everyone. Back to you, Carl.
Thank you, Edmund. Are you guys excited about our projects? So currently the brain-computer interface and the radiology project are open for application. We're looking for a student with biomedical background that can understand the research and contribute their domain knowledge to the problem. You might think that someone can't program or have no engineering skill shouldn't be part of the team, but domain knowledge can help us, can play a huge role on the efficiency of the project, and it can prevent us from doing something that's completely irrelevant to what happens in the clinic or in research. We're also looking for people with technical backgrounds to implement the project. So the 2 projects on the advertised right now is looking for people with machine learning skills and software engineering skills. Particularly the radiology project is looking for this type of student. And for the upcoming project, we probably need people who are interested in software development and app development. And within each of the projects, we're also hoping to take 1 or 2 students that are really new to the subject area and may not have the technical expertise yet. But if you demonstrate enough interest and passion to learn about these medical technologies, we would love for you to apply for our projects. If you're still not sure about the project experience, we have brought one of our project mentors to the event today to talk about his experience in biomedical engineering and his career working in interdisciplinary team. So allow me to introduce Dr. Sam John. He is a senior lecturer of the Department of Biomedical Engineering. His primary research involving developing the next generation of implantable neural prostheses that interact with the nervous system. His research draws from his background in medical electronic, electrical and electronic engineering, and neuroscience. He was part of the original team that developed the Central Technology in Melbourne University, who awarded the 2019 Eureka Prize for Interdisciplinary Research. He has previously worked as the lead software developer in Synchrotron Australia, which aims to commercialize a minimally invasive brain-machine interface. Please welcome Dr. Sam John.
Thanks for that. Now, hopefully, I've got cool. All right. So I think there was just a couple of things that I was asked to talk about. Firstly, who am I? So I am a senior lecturer, as I was introduced, at biomedical engineering. I've been part of multidisciplinary teams pretty much my entire career. So I started off with working for cochlear implant, working with cochlear implants earlier in my master's degree, worked with CSIRO on a few different projects on ranging from mineral processing through to developing a device that can detect how bubbles interact in water and how we could use that to measure pressure. And I was working within a team in CSIRO particularly where we had material engineers and people who work in mineralogy, and then bringing all of that experience together in making their devices. And particularly that bubble project was really interesting because the origin of that project where we could measure pressure using just how bubbles resonate actually came from oceanography, looking at how bubbles make sound. So whenever we think about ocean current, or when we think about waves and you hear the sound, we never really think about where does the sound come from. And without the bubbles, you actually don't hear any sound. And it is those bubbles that make the sound. So I guess, yeah, everything that we kind of do in medical research is pretty much multidisciplinary research. And it is extremely important. From CSIRO, I did go on to work with the Bionic Eye for my PhD, and then went on to work with Synchron Australia in the minimally invasive Stentro technology as well, which led me on to brain-computer interfaces. Now, all of those projects do have one thing in common, and they're all multidisciplinary. And it's pretty much like if we had people, for example, in the Bionic Eye from optometrists, ophthalmologists, vitreoretinal surgeons, engineers, scientists, and a whole bunch of people being able to work together. And without that, we wouldn't have been able to make a Bionic Eye work the way it does. And it's the same with the Centro project as well. So is it important to have multidisciplinary research? Absolutely. There are so many different things that we can bring from those different areas that we don't think about them the same way in another area. Some of those concepts are similar, but we don't actually think about them in the same way, which allows us to bring in new ways of mixing those ideas together. I guess, how did I get here was the other question. So I started with, well, I started my master's at cochlear implants. And when I first was introduced to the idea of cochlear implants, I was amazed that we could take electronics, which I really love, and put that into the brain and restore function to someone. And that was mind-blowing for me. And ever since then, I've been hooked on neural engineering, which has brought me all the way through to now, where I'm working on brain-computer interfaces. I think I'll leave it at that. That was 5 minutes, right?
I think Betty's Zoom connection just dropped out. In any case, are there any questions from the floor for Dr. John? I'm just scrolling through at the moment. Yeah, I don't see any. So I might just ask one of for myself. Obviously, you are a project mentor for our brain-computer interface project. Can you let us know, like what you see in Embassy and how do you think that we can contribute meaningfully towards brain-computer interface, which is obviously a very, which is an area that you have a lot of interest in and has been a lot of your career.
One of the best things about Embassy is that it is opening the doors to kind of talk amongst student groups which normally don't talk together in a lot of ways. So once you finish your Bachelor of Science, for example, a lot of the students probably work more in silos, or most of us would work in silos unless there was a reason to bring us all together, right? And I think this is giving a reason to bring everyone together. And two, everyone who does join is joining because they're interested in a particular topic or a particular area, which is also good because there is a lot of initiative there from individuals and a reason to make it work, which is wonderful. And I think those two things, the initiative that you have as well as a multidisciplinary team means that you'll be able to think of problems in completely different ways than you would have if you only worked on it yourself. And I think John was saying earlier that teams are really important, but multidisciplinary teams are really important as well. And the more ideas you can get from different areas, the more diverse your ideas can be, the better your project will go as well.
All right, lovely. Thank you so much, Dr. John. I think, actually, Betty has a question as well. What are the different types of roles in Medtech? Now, we often hear about founders, but what other employment opportunities exist in the field?
Yeah, well, what are the different opportunities? So I guess you could, the ones that we know of most often is that we think of founders, we think of researchers or in academia, but there is a lot of other important roles. And one of them is regulation. How do you actually take an implant and make sure that it is safe? And we've seen a lot of failures in regulation in the last few, probably 10, 15 years, from hip implants to vaginal meshes that didn't work or weren't really well thought through. There's a lot of loopholes that can occur and lots of things that can go wrong. Regulation is one of those areas where it's important to make sure that we understand what does it mean to be safe and what does it mean for the general public. Also, government policy. Government policy is sometimes can feel like it's not in step with what's happening. However, it was really nice to see science being talked about in Parliament, which doesn't normally usually happen. But being able to talk about medtech in politics is great. And we do need more people who understand medical technologies, who work in government, in all areas of government, state, all the way through to the federal government. A lot of technologies that do go in and lots of treatments that make it into the reimbursement scale, I guess, when you want a treatment to be funded, it has to go through the government as well. And so it's good to have people working in government, people who have good attention to detail and who can understand the technology. I can keep going. There's so much more that can be done. Intellectual property is another big one. But again, there's lots of people who work at IP Australia, and they're always looking for great graduates who understand medical technologies well and are able to assess whether technology is novel or not. So yeah, the limits of these are, there's so much you could do.
All right, thank you, Dr. John, for coming to speak with us and also sharing your insights. I think we might move on to our educations portfolio. And for that, I'd like to introduce our lovely educations coordinator. Oh, actually, no, before that, we have an extra slide here. Carl, do you want to speak on this?
Slide in one last quick recruitment message. We're also looking for project leads. If you're someone that has a burning passion for some medical technology or medical need that you want to attend to, and you have an idea that you're not sure how to get started, or you're someone that's interested in going through the biodesign innovation process and hope to do that as a student at the volunteer, please contact us. We'll be releasing a project lead recruitment document in the next few weeks, but you keep an eye out on Facebook page, but don't be afraid to just reach out to us right now and let us know.
All right, thanks, Carl. And now I'd like to introduce Annie, who is our lovely educations coordinator, to come and speak to us about the second of our two domains, which is our educations portfolio.
Thank you so much, Alan. And thank you everyone for joining us here today. I'm Annie. Just a little bit about me. I'm originally from New Zealand and I came to Melbourne to do my Bachelor's of Biomedicine, which I'm in my final year of, and I'm majoring in biomedical engineering. So I am the education coordinator and I work very closely with Ryan, who's our Vice Chair Internal, and we oversee and lead the educational aspects of MBSI. Next slide, please. So our education team has two main aims. First of all, we aim to generate interest in medical technology, especially in students who do not come from a biotech background. As Alan and Sam John has mentioned before, medical technology is a very multidisciplinary field. So no matter what educational background you come from, we want to show students that they have the ability to contribute and we want your input. So the way we are planning on generating interest is through holding educational workshops where students can learn about medical technology through application rather than just learning the theoretical side of things. We're also planning on collaborating with various student industry professionals in these educational events. So there'll be opportunity for students to interact with people already working in the field. Our second aim is to equip students with the skills and knowledge that we believe will be useful in the field of medtech. Part of this goal is to assist our existing project teams, as Carl have already mentioned, by introducing new technical skills that may be useful to their research. Another part of our aim is to provide students who potentially want to join our project teams in the future with the basic technical skills to do so. Our workshops are going to be of varying difficulty so that students of different levels of proficiency can all join. This year, we are planning on holding workshops in programming and Python for beginners, introductory bioinformatics workshops, which is a little bit more intermediate level, data science discussions, and we're also planning on holding a workshop series on the biodesign implementation process that David Graden had mentioned before. So now I'd just like to pass on to Alex, who's our coding officer, and he'll be talking about our beginners programming workshops.
All right, thanks Annie, and hello everybody. My name is Alex, and I'm currently finishing my master degree in Master of Biomedical Engineering this semester. And I'm very happy to be one of your student tutor in the coding workshop this year. So if you're curious about what is programming, or you want to know more about how programming is actually related to the area, such as medical research or biological research, or you simply just want to learn some codings for the projects that you're going to attend, or come and join us, of course, it's for you. The workshops are designed for beginners, as we said. That means you don't really need to have any experience or background to attend. We will cover all the fundamental ideas, and you can learn what is programming, its popular applications, and how to use Python eventually. We're not expecting you to be a professional programmer, but you're expected to understand some basic ideas of Python and how to use it. Finally, we do hope that you can write some simple programs yourselves at the end. The total time commitment of the workshop each week, we think is less than 3 hours, so that you can spend 2 hours with us and 1 hour maximum for yourself as practice if you really want to. After completing the series of workshops, if you still want to keep your journey, and you're more than welcome to join our bioinformatics workshop later this year. And finally, I want to emphasize that our first workshop will actually be on next Wednesday, which is 7th of April from 6:30 p.m. to 8:30 p.m. So now I'll pass to Vincent for more about our bioinformatics workshops.
All right, hi everyone. I'm Vincent, and I'm currently in my final year of Masters of Biomedical Engineering, and I'll be one of your bioinformatics workshop officers for this year with Jack over here. I'm excited to bring you our series of bioinformatics workshops starting in semester 2 that will introduce you to the world of dealing with large sets of biological data. This series of workshops will follow the same format as the coding workshops that Alex has introduced, with weekly workshops of 2 to 3 hours. You will be investigating the breakdown and interpretation of bioinformatic data, and in particular, genomic data. As genomic sequencing technology advances, more and more data is becoming available to us. In order to process the large amounts of data being generated, it's important to learn how to curate and manage it. From this data, we can investigate the changes of genes in a wide array of applications, such as disease control and super efficient crops. We will spend our time getting familiar with the BioPython package to analyze gene sequences, and also we will navigate genomic databases to find our relevant data. Our series of workshops will culminate in investigating gene sequences in COVID to glean any insights as to what makes this virus so potent. So all you need for these workshops is to have an interest in bioinformatics. Prior coding experience is desired but not required, although it would be easier for those of you who have attended the coding workshops. More information will be released closer to semester 2, so stay tuned and I hope to see you guys there. Now, on to Ryan.
Thanks, Vincent. So my name's Ryan and I'm the Vice Chair Internal of MBSI. I'm in my 3rd year of a Doctor of Medicine at the University of Melbourne and completed undergraduate degrees in biomedical engineering and pharmacology from the University of Auckland. With the introduction of electronic medical records, we're generating masses of medical data. Biomedical data science is becoming increasingly important to glean meaningful insights from this information. This is the motivation for our data science discussions, which we're hoping to run monthly in collaboration with the Centre for Digital Transformation of Health, directed by our guest speaker, Wendy Chapman. In these discussions, we'll talk about interesting biomedical data science topics and learn some useful tools. The discussions will provide the project teams with technical guidance, but will also be open to members of the general public. Attendees will have the opportunity to ask questions and network with CDTH researchers. Our first discussion is planned for late April. And as our first speaker, David Graden, mentioned before, biodesign innovation is a process for developing medical technology. He runs a course for Masters of Engineering and MBA students, but it only has limited spaces. So we want to give a taste of biodesign innovation to students who are interested in biotech or medtech innovation, but aren't able to enroll in the course. We want students to learn how to find and screen clinical needs, generate and select concepts, and develop an implementation strategy and business plan. We hope to do this through a competition where students apply their skills to a clinical problem in small teams, culminating in a pitch event for students to present their ideas. Hopefully, this competition will generate future projects if students want to develop their ideas further. We're aiming to run this in early semester 2. Next slide. We have a few opportunities available under the education portfolio. Firstly, we need more bioinformatics workshop officers to help us design and deliver our workshops. We've just started planning the curriculum and Annie and Vincent would definitely appreciate the extra help. We're looking for people with bioinformatics experience, preferably using Python and an interest in teaching. If you'd like more information, we've posted a position description in the chat. We also need mentors for our biodesign competition to teach biodesign innovation principles and guide student teams. We're looking for people with experience in the biodesign innovation process, preferably alumni of the University of Melbourne Biodesign Innovation course, but also clinicians with medtech startup experience. We're still in the early stages of planning, but we'll send out an advertisement soon. If you're keen to volunteer for either of these positions, please send an email to education@mbsi.org.au. Next slide. So our final guest speaker is Professor Wendy Chapman, the Associate Dean of Digital Health and Informatics at the University of Melbourne and the Director of the Centre for Digital Transformation of Health. She has a PhD in biomedical informatics from the University of Utah and moved to Australia in 2019. Her research interests include natural language processing, knowledge representation, and application of informatics to clinical care. She'll be talking about pathways in medical and biotechnology. Over to you, Wendy.
All right, thanks. It's a pleasure to be here and so many exciting things going on. I just want to tell you a little bit about the center and what our purpose is. So this is a new center at the university. It's co-sponsored by the Faculty of Medicine, Dentistry, and Health Sciences and the School of Engineering's Computing and Information Systems department. So we are a hub to bring together the multidisciplinary groups of people to work on problems of how to improve healthcare outcomes that matter to patients and to clinicians through data analysis and innovation, application of innovation into healthcare. And so we have 3 aims in our center. The first is education, and we will be developing a lot of different workforce training, kind of short courses. We have a graduate certificate and a track and a master's program that we'll be redesigning and working on integrating digital health and informatics education into existing programs like with the MD program and others. The second one is data-driven healthcare, and really, how do you collect, manage, and analyze clinical data, and how do you use it to learn and drive the learning health system so that we are always improving what we're doing based on our past experience. And the third is what we're calling the digital health validitron. And this is an innovation pipeline similar to the Biodesign program, but really focused on information communication within the healthcare system and with patients, on creating kind of a connected journey between patients and their care teams. And so that is an innovation pipeline that will be bringing industry and researchers through to be able to evaluate their innovations in real health settings. And so we look forward to interacting with you through the many different mechanisms and welcome anybody to stop by, stop by virtually for now. And in the future, we will be in Melbourne Connect soon, and we have space in the Victorian Comprehensive Cancer Centre as well.
Thank you so much, Wendy. And just in the short amount of time that the centre has actually existed, it's already made so many interesting contributions, and we can't wait to work with you further. So I have a quick question. Would you be able to share your personal pathway into becoming a medical informatician, and what sort of turns took you to where you are today?
Yeah, I'd be happy to do that, because a lot of us, you'll find that when you get to your final career, it's often a meandering pathway. And one of the challenges that we all face is confidence in feeling like we can really make it where we're at. And so I think my path is an instructive one, because I started actually in elementary education. And then I went to Hong Kong and I learned to speak Cantonese, and I fell in love with language. And so I came back and I thought, well, I'm going to switch my major. And I switched to linguistics, and with a minor in Chinese. So I was in the humanities area, firmly, and my husband was in electrical engineering, but he wanted to do medical applications. So he found this field called medical informatics, which was the first department of medical informatics in the US was at the University of Utah in 1964. So he signed up for that graduate program, and I learned about natural language processing, which is trying to extract information out of the clinical notes that are dictated or typed and stored in the electronic medical record. And so I decided that might be a really nice way to apply my love of language. And they let me in on probation, because I had calculus, but I didn't have any science, never had biology or physiology, and no computer science. So I was let in on probation. I proved my worth. It took me 6 years to get my PhD. And then from then just, kept moving through the field. So it's just, you just never know where you're going to end up, and take opportunities that present themselves, and don't be afraid.
That is incredibly inspirational. I can't imagine what a massive change that would have been from primary education to natural language processing. And unfortunately, we don't have any more time for questions to Wendy. So I just want to thank you once again, and also give a shout out to Wendy's husband, Brian, who has been mentoring our team in delivering the data science workshops. So be on the lookout for those amongst our really exciting education programs. Thanks so much once again, Wendy. And our next speaker will be our fantastic events coordinator, Alina, who will be sharing with us some really exciting activities that will help you all catch up and engage with MBSI.
Thank you so much, Betty. So, hello everyone. My name is Alina and I'm the events coordinator of MBSI. I'm currently pursuing my Master of Engineering in Biomedical with Business. So, as the events coordinator, I love events. And why is that? Because events are incredibly important to build a community, especially within MBSI, such a new fledgling little organization. So, with events, we can develop our social and communication skills and also have an excuse to party. But that's besides the point. So we have a great lineup of events this year, starting with a murder mystery social, which will be held in week 8. So murder mystery, that's kind of like the antithesis of what we're trying to do. We're trying to save lives, right? So a murder mystery is a social deduction role-playing game very similar to Among Us. It's a great chance for people to get to know each other in a very, well, easygoing setting, with the added side benefit of improving, well, our members' oral communication skills, deduction skills, and, well, problem-solving skills. All of these things which are incredibly important in our industry. We will also have a series of industry nights held over the course of the year. These are a series of talks in which industry representatives will come around and share their knowledge with our members. Kind of like how our 3 guest speakers are here today and have been sharing their knowledge with you. We will also have pitching presentations, which will be held at the end of the Biodesign Innovation Workshop series, as mentioned previously. This is a chance for members to practice their professional pitching skills to a panel of experts in preparation for the Inaugural Symposium. So, the Inaugural Symposium will be held at the end of the year, where our project teams will come together to pitch and showcase their work to the entire organization. It's kind of intimidating to do that, but that's what we're here for. We're here to upskill you. So, it will be a great celebration and chance to party of the cumulative work of the initiative. Not too dissimilar to a gala. Well, I think I've made my pitch too. So that's it for events. And now I'll pass it back to Ellen to wrap up this whole presentation.
Thank you so much, Alina, and I'm so excited for all of these events, but also Murder Mystery Social sounds amazing. Anyway, so I am aware that we have gone slightly over time, but that's okay. Thank you so much for sticking with us throughout. And we are actually at the end of the talk anyway. So just to quickly wrap up some important key takeaway points, we have a number of positions currently open if you want to join MBSI or get involved with MBSI. We currently have a number of project teams requiring members. We also have 2 open spots in the committee. So if you want to contribute towards steering MBSI, then we highly encourage you to apply. Applications will be closing in a couple of days, so please get it in as soon as possible. If you have any questions for us, feel free to ask now. Now is the time in which you can unmute yourself and just shoot us a question about anything we're going to be doing at MBSI. Otherwise, if you want to send us a contact email at this email or just message us on Facebook or message us individually, that's also absolutely fine as well. But yeah, so any questions from the floor at all?
Feel free to unmute yourself.
Any in the chat?
No, don't have any at the moment.
That's all good. We've been like bombarding you with information anyway throughout the entire
Okay, we have
night.
a question from Tony,
So,
actually. So,
oh yeah, so do you have plans to extend your programs to other cities? There is, in theory, no limitation on where we want to operate. So if, for example, we have project opportunities or mentorship opportunities from academics or clinicians in other cities, absolutely. In terms of whether or not we'll be starting teams in other cities, well, if there are space for collaboration with members from across Australia or even across the world, that's definitely open as a possibility. For the moment, just because we're starting, we've only literally just started out, and the core, the core membership and volunteer base for the organisation is at Melbourne. We'll be trying to sort of focus in our attention on Melbourne at the moment. But to sort of answer your question, no, there is no theoretical limit, but for now, we do want to limit it fairly locally, just so we can get started and then dream big later on.
So our project teams do require attendance at in-person meetings, but a lot of our education programs, such as the coding workshops, will be delivered online or in like a hybrid format, so you can join us from anywhere. Cool.
Cool. All right, I think that might do us for the evening.
Before we leave, I would like to take a screenshot of this event. And so if you would like to switch on your cameras, please do. And okay, let me figure out the right shortcut. Okay. Taking a screenshot in 3, 2, 1. Cheese. Okay. Oh, we have to do it again. Sorry. Someone just messaged in the chat. All right. 3, 2, 1. Cheese. Amazing. Thank you, Po, for holding your victory sign the entire time. That's fantastic.
All right, I think that does us for the evening. Thank you so much for coming tonight. Apologies that it ran a little over time, but hopefully you got a good idea of what Embassy wants to do this year, and we really hope that you feel inspired enough to join us and or to take part in what we do. All right, see you guys.